Hi all, this is Mohammed Mokbel, author of SPF ShellPcapFication framework. So today we're going to be talking about a new feature I've added to SPF called Implicit Constructors. So it's a part of Eros language in particular. But before I talk about it, I would strongly recommend that you will first watch my presentation about SPF that I gave in September of this year at ToolCon conference, because this feature is dependent on other features of SPF. So you need to know those features first before delving into this new feature. If you don't want to watch the presentation, there's always the documentation, which is thorough. Nonetheless, I will provide a link to the presentation in the blogs down below for your own reference. So without further ado, let's jump ahead into the new feature. So first, I'm gonna start with the documentation, and I've already documented the new feature. So, and it's located under Implicit Constructors. So here it is. So what are implicit constructors? They are special functions that can be used to initialize the logic of all constructs at once, a set of constructs, or a construct. How? Either by prefixing or suffixing the logic definition of a given construct. And how do you reference it? Via the auxiliary logic definitions. So as a recap for what an AL is, it's nothing more than a macro, just like in C language. So what is where the power of implicit constructor lie? It's really provide a powerful mechanism for default initialization of SPF or wing construct logic. So you don't have to reference those implicit constructors anywhere in the logic definition of a given SPF or wing construct. And this is the power of implicit constructors. They work exactly just like constructors in a high-level language. So when you instantiate an instance of a given object, and that object belongs to a class, and in that class you have a construct defined, right? So every time you instantiate an object of that class, it gets instantiated with whatever value you have defined in the constructor of that class. And implicit constructors works in a similar fashion, if not the same. And so you have two specifiers. You have prefix and suffix. So you can prefix the logic definition of a given construct with whatever value you have, and that value is defined in a auxiliary logic definition. So you use the auxiliary logic as a mean to reference the value that you want to have prefixed to your construct. By that I mean the logic definition of your construct. And the same thing goes for suffix implicit constructors. This is as well for appending whatever value you choose to the logic definition of your SPF or wing construct. So for implicit constructors, they have scoping boundaries. You have either global boundary or local boundary. And of course for global as well, it goes the same for SPF or wing construct types, and for both specifiers, prefix or suffix. And the same thing for local. So for the global ICs, so therein I'm gonna refer to implicit constructors as IC. And this is the skeleton of how you define an implicit constructor in your translation unit. So first you say, I need to prefix every SPF construct I have in my translation unit, or every translation unit you have, with whatever value I have defined in this auxiliary logic I'm referencing here. So, and this here, this literally means I am talking about a global IC here, right? So every time SPF parser sees this skeleton, it's gonna take it as a global IC. And the same thing goes for every other construct type and specifier. It is that clear, I suppose. And here I showed the declaration rules as well as the definition rules for the global implicit constructors. So those I'm going to leave them to you to read them on your own. So here I have this node. So what happens if you define two global constructors of the same type? Let's say you have this prefix SPF global IC, and you have another one of the same type as well in your code. Well, it doesn't make sense to have multiple definitions of the same construct type global IC, right? Why? Because it doesn't make sense at all. So what would happen in this case is that SPF parser will complain about it, emitting a warning message to the console window and saying that only the first definition will be taken and the rest will be ignored. So technically SPF still works, but it is a warning that you're going to get every time you run SPF. So it is better to rectify before using it. So this is global ICs in a nutshell. I guess they are that simple. Yeah. So here's an example of how you would define your own global IC. So first, you define whatever auxiliary logic you want. So here we have this auxiliary logic called display filter, and I'm giving it this value, space -y space. Just refer to this one here. So what does this value mean? It's used with T# display filters, and this is the argument you use to define your display filter. So as you can tell, it's not an actual logical statement on its own. It's just an argument. So when you define a construct and you have to reference this argument, it doesn't add anything because it's not part of the actual logic of a display filter. So, and if you want to define this here as an auxiliary logic, and just so that you can separate the logic from these non-logical statements, then you would have to, and you don't want to use an implicit constructor. In this case, you would have to use a referencing object, right? In this case, it would be an insert operator to reference the auxiliary logic. But that's still a lot of work. That's why I provide implicit constructors. So again, a global implicit constructor will literally, for example, if we're talking about a prefix SPF, it will prefix every logic definition you have for whatever construct type SPF with whatever value you have defined in the referenced auxiliary logic definition, all at once. So this is the power of it, so that you don't have to repeat it every time. And let us say you have to exclude a construct or a set of constructs from that global IC scope. Right? So what would you do in this case? For that, there is the following statement that you can use. And it is as simple as prefixing a given construct you want to exclude with this negation operator, right? And you can have multiple constructs here, and they all have to be separated with a comma. And yeah, and the same thing goes for the others as well. So if you have a win construct type prefix, so here bear in mind that you cannot reference a win construct type inside of an SPF statement. Otherwise, the parser will emit a message telling you that you're violating such a rule, and you have to rectify it before proceeding ahead. So these exclusion operators they are only relevant technically when a global IC is present, right? Otherwise, why would you be excluding it? With respect to what? So this is a global SPF and exclusion, global ICs and the exclusion of a given construct in terms of global IC. The exclusion specifier, again here I'm having this node, is only relevant when a respective global IC is present. So now we go into local SPF and Win implicit constructors. So local is literally for referencing a specific construct or a set of constructs instead of applying IC for all constructs at once, right? So let us say you want to prefix only a construct or a set of constructs with whatever value you choose to set in whatever AL you define, right? For that, you just, again, the skeleton is similar to the global. So instead of using the start operator inside your parentheses, here you would reference a given construct you have defined your translation unit. And the same thing as well goes for the other construct types as well as specifiers. And what else? Yeah. So here, bear in mind that you cannot have multiple definitions of these local SPF and Win ICs and both referencing the same construct names, right? So, how would SPF parser knows which one to take? So in this case, if you have multiple definitions that are both referencing the same construct, SPF will complain about it, emitting a warning, or I should say error message to the window, saying that there's multiple definitions of the same, or there's multiple references of the same construct, and you have to rectify such violation before proceeding ahead. But nonetheless, SPF will take only the first reference. But every time you run SPF, you're going to get the same message. And this is how you define the local IC. Again, you say what direction you want. So talking about a prefix, and for this construct type SPF, and I am checking only these constructs that I have defined in my translation unit called get URI and domains. And for each of these constructs, I am assigning the value that I have defined in this display filter auxiliary logic, right? And here I have another definition of this IC referencing a different construct, and I'm also assigning it the same AL definition here. So like this is just for illustration purposes. So we have these constructs. So we have them defined in our translation unit as a part of Eros language. So how would you access them from the shell? For that, I provide the helper command called GIC, and GIC technically stands for Get Implicit Constructor. So let me show some examples that they've already implemented. So here for that, I'm gonna go to the main cmd.spf translation unit, and this is exactly the same example I have in the documentation, right? So there's nothing new here. And here, this is the exclusion operator for SPF construct type. Do not prefix I'm saying do not prefix this particular construct when you see when you go through all of the constructs, because I have this global IC here defined that would assign this value to every logic definition of all SPF constructs, right? But for this one, this value is not needed. That's why I am explicitly excluding it from this process. And there is also this one here. Sorry, this is where we talk about multiple definitions. So here, again, I'm referencing the specific construct, but I'm giving it a different AL definition here, which is this one here, right? So this construct doesn't take, or I should say, it does not start with this value because it's different. And I've already talked about this particular example about the black nurse denial of service attack and how you check for that using T-Shock display filters. For that, I would recommend that you watch the presentation. So I'm gonna go to this particular construct and show you the definition. And here is the definition of this construct. Right? So we have SPF here. So we have these two AL defined. Although they are locally defined here, but their scoping is global. They are accessible by every other construct. So yeah, so this is the name, this is the logic, and as you can tell, I have separated here the logic of this filter from those two arguments that it has to start with, right? Those two arguments here, because they do not provide any logic, any actual logic. They are just opening parameters, right? That's why I'm using an implicit constructor in this case. And as you can tell, I don't need to reference it anywhere in the logic definition of this construct because it is an implicit constructor. And this is the power of IC. So it makes the code clear and void of any non-logical statements. And what else? So yeah, this is ICs in a nutshell. I strongly recommend that you read the documentation in full from the beginning, or you watch the presentation, because as you can see, this is dependent on other things that you need to be aware of before watching this video or even attempting to use this feature. So let me give you a demo about this feature in the tool. So for that I'm going to open the 32-bit version, and this is SPF. First I'm going to show you how to the helper command GIC. For that it is referenced here. So here for GIC, which is also documented in the documentation. So let us say I want to get a list of all prefix SPF global ICs. Right. For that, I would say this get IC. I want prefix. I want what construct type, SPF, and what scope, global. Do I have any? And here it tells me, yeah, yes, you have this global IC defined that references this particular auxiliary logic definition, right? And to get the value of this AL, all you say, or AUXL, auxiliary logic. Let me see, it's not showing here in the window. Let me just. And here you say auxiliary logic, display filter, and here it's going to give you what value it's set to. So if you don't give AUXL a value, it's going to give you a list of all defined ALs in your code as such. And what else? Yeah, so as I showed you here, this particular construct doesn't have these valves defined in the actual logic definition here in the code. But if we go here to the shell, so when you execute the shell, it parsed everything for you, right? So everything is already ready for execution. We can inspect the logic definition of this particular construct to see how it looks like now. First, let us use this command to get the list of all constructs that are available to us from the shell. For that, I use the command get all commands, right? And here it tells you that this construct is available under this structure, external SPF command list. And let us inspect the logic definition of this construct. For that, I would use the command logic, and I give it the construct name that I'm interested in, black nurse, right? And then here, it's going to show me the logic as SPF shell sees it, right? So here you can see that it's been already prefixed with this AL, you see? So yeah, this is how ICs work. I guess that's it, and I hope you enjoyed this short presentation about ICs. In case you have any questions, I'm more than happy to answer them either by emailing me or asking me on Twitter. Yep, and thanks for listening. I hope you have a good day. Bye.